Good morning, Jan.
Michael, good morning. How are you?
I'm doing very well. How about yourself?
Very good. I saw some good news when I started Discord. It says new feature, you can have a video background.
Ah,
So that will allow me to clean up the mess behind me without cleaning up. Yeah,
very nice. Yeah, yeah. I wonder
it has been.
what service they're using for the rotoscoping. That's
Sorry?
I
Sorry?
wonder
What?
what they're using for the rotoscoping, detecting you versus background. Is that
Oh.
that's
Hmm.
kind of a hit and miss thing with like Zoom does it okay.
Well, especially headphones.
Mm-hmm.
Then they take out the headphones a little bit or not at all. Yeah, I think a better solution will be that I clean up the mess.
Yeah, but
Yeah.
that that's on brand. That's what we've come to expect. Is that you're a busy guy.
Yeah.
There's all your stuff.
Well, let's say that's the disadvantage or the advantage of an office where you don't receive customers.
Mm-hmm.
You don't have it's only me in here and nobody ever comes in. But video conferencing has changed that a little bit, so um, I should
Yep.
clean up.
Whereas
Okay.
I just like to put my hobbies on display. So got my new sand
Yeah.
crawler uh, out there in the dune sea.
Okay. No, you have a very nice background there. Uh,
Yep,
that's made for.
that was all my daughter.
You have professional support. Uh,
Yeah.
yeah. Good. So last time I was we were struggling. There was still some. It was not working. I still needed 5 minutes,
Hmm.
and then after half an hour it was working. So I was so happy. I was so proud. So I sent you that mail, and then after that mail, I clicked once more, run test. Didn't work anymore. I click once more. I said, "What's happening?" 3 times didn't work. 4th time it did work. 5th time it didn't work.
Hmm. Okay.
And so the rest of the day, I didn't succeeded in making it work. If I remember well, first thing I discovered what was I ended with a read-write connection
Hmm.
and a connection for reads only, if
Right.
I'm not wrong. And then I discovered that actually you cannot have two transactions on the same connection.
Okay.
Because if you have a transaction and you start on the same connection another transaction, it will be a nested transaction. It
Okay,
will
that
not be
makes
a
sense.
parallel And anyway, SQLite doesn't accept with a normal syntax nested transactions. With a special syntax, yes, but that's not our purpose.
Right.
So
Right.
then I converted back to every transaction in its own connection,
Hmm.
but it still didn't work the way it should be. And then I say, okay, let's go back to basics.
Hmm.
Um, because then I started thinking, probably I'm wrong, but perhaps I'm just misunderstanding the documentation of SQLite and imagine that SQLite is not doing what I think it should be doing, then we are wrong. So let me show you. Um, is it the window of the virtual machine? Here we are.
Hmm.
Is that readable?
Yes, it is.
Yeah. So then the last time I saw pointers was probably 30 years ago at the university. But since SQLite is written in pure C, say, okay, let's avoid everything, all the layers between. Let's avoid all the trouble that we might have with async and wait, all timing issues. And just what I did last time in C sharp, let's try that test from
Hmm.
C, pure C.
Okay.
That's far from my comfort zone, but
Hmm.
um, So luckily there is pre-roll site, some courses, there is the internet. But finally I got something working. I had no time, but I cannot leave. I cannot stop if it's not working. So I had to make this work. Um, so the main routine. Here I'm just getting the started time that I display.
Mhm.
I start from a database that I already made from the C# uh, code.
Yeah.
Anyway, if I leave out that place, that code from C# and I reuse the existing database, I was having the same problem. So I just delete all the records in the database. Then I start a read transaction. That's the read transaction before the writing. Then I start a write transaction, all on a different thread. So it's multi-threading here.
Mm-hmm.
Then I start a read transaction, which is started during the writing transaction.
Yeah.
So that one should not see what is being written before or what will be written afterwards, because it started while the writing transaction was active.
Right. Yeah. So I see sleep for half a second. So the write transaction has a longer
Yeah.
sleep in it, I'm assuming.
The write transaction is writing 10 records with every time 300 milliseconds
Okay.
between it.
Yep.
And then I have another read transaction which starts after the write transaction finishes.
Mm-hmm.
So a read transaction which starts before, which starts during, and which starts afterwards. So if we go to that, then here, compile the thing again. So Visual Studio Code is working very nice with that GNU compiler. And clear SQL test, if I run that, almost finished. Yeah.
Mm-hmm.
So if I make that bigger, so I started the program here. That was 3655. Deleted all records, started, ended. That's synchronous in the main thread. And then I started read before thread. That's just the thread ID.
Mm-hmm.
The first thing I do in that read before thread is a select count to see how many records I read. And my select count star is giving nothing.
Right.
After that, I will read all the records, but there are no records.
Mm-hmm.
I will wait 5 seconds. I will read again the records, and I will end with another count star.
Okay. Right. So that's ensuring that your transaction is isolated from any writes that are happening.
Yeah. Then I started my write thread. That's again the thread ID, which is different from that one.
Mm-hmm.
He inserts a first record. Second one, you will insert 10 records. And in between, you see that the read during thread is started.
Mm-hmm.
And that one says, I don't find any records.
Yep. Transaction has not been committed yet.
The write transaction has not been committed yet. And then after 300 milliseconds in between every read, so after about 3 seconds, he ends the write thread. And then he starts the read after thread,
Mm-hmm.
with the thread ID again. So the count tells me 10 records. He will read all 10 of them. That's exactly what I've been writing here. Yeah, you see the same values. Then he's still doing that read before thread. there he finishes with a count also. He said, I didn't read anything. He ends the read before thread. The read during thread, he also finishes with a select count, 0. And so he ends that one. And then after 5 seconds, he's reading again in the read after thread. And he does a count again. And then he ends it. And so he ended at 37,004. We started at 55. So it's about 9 seconds, which is actually the 5 seconds from a read thread, plus 3 seconds from the write thread, because we're doing the write first, with a few reads in between, but only when the write stops, then you start the read after. So you have to sum them.
Yes, that makes sense.
And so I've been running this multiple times, and that works fine. And if, for example, there's all the other ones. Here's my code now. If we take out, this is not nice code. That's the write transaction. Okay, so that's here my write transaction. If, for example, I would say here, that is begin transaction statement. So if I comment that out, and here is the end transaction. I comment that out.
Yeah, now we're going to see crosstalk.
Yeah, so now the read transactions, they still have, let me compile that again. The read transactions, they still have, or the read operations are still transactional. The write, not anymore.
Right, yeah.
So, yeah, there you see it already. Let him finish completely. Yeah. So we started here. We deleted our records. We started read before. Here we start writing. We have written 2 records.
And then we read during.
Read during says, I found 2 records, which he displays.
Yep. Yeah, that makes sense.
Because
so SQLite creates a transaction around the insert operation, but all of those inserts are no longer inside of a transaction.
Yeah. So now the read during thread is actually started while there were already 2 writings executed. So the conclusion is SQLite is working fine. That's the most important, because the other things we can solve. That's a matter of searching. Actually, SQLite is having a lot of diagnostic tools. For example, if somewhere an error occurs, you can it will call a callback that will do whatever you want. So write back the errors to a file, for example. So all these little things that make troubleshooting a lot easier if afterwards we have problems in the field.
Yeah. Okay. Good.
But to get that working, it's enough that just one pointer or just one parameter towards the DLL calls is wrong, and it doesn't work. So I prefer to test it out on the lowest level. At least I'm confident now that it works.
Yeah. Okay. And so SQLite-net also has connection pooling built in. It doesn't look like just SQLite itself offers that.
Well,
one level higher.
The SQLite-net I already left out last time.
Oh, right. Yeah. You were just using that as the.
I was using this lowest library, which is the SQLite PCL raw.
Okay, right.
But even that is still a lot of code. So there Probably I made a call with wrong parameters or something wrong in my async and await code. I will find out, but um, at least now I know that
Hmm.
the underlying thing is working without any problems. That's the most important.
Okay, yeah, good, good. Um, so going forward from here, I could see a couple of different paths. One path is to go all the way back up to SQL.NET and just do the simplest thing possible. Don't try to optimize. So, for example, every time you need um, to to do something, you will go ahead and just create a transaction or create a connection and do it rather than keep a couple of them. Um, and then the other path I could see is take this and build up from here, and um, and tunnel this into .NET, perhaps using SQLite Raw, um,
Hmm.
and then just uh, get this exact same thing working from .NET, and just build up. And anytime it crosses over into the not working side, then you keep working on it until it's back to working reliably, and keep going.
Hmm. Um, I think the optimization we can that's something we can do afterwards. But it's important that we are sure that everything works correctly.
Mm-hmm.
Also, initially, if we use a library and it doesn't work correctly, um, if we cannot trust the database infrastructure, yeah, then debugging will become a nightmare.
Yeah.
So what I would like to do now is um, go back to C sharp, main, use that PCL raw layer, which is actually just a translation layer, a connection layer between C and C sharp, but it doesn't really do a lot of processing.
Mm.
What what
Yeah.
it what it does do is, for example, it allows you to automatically take the correct database. Um, for example, on .NET, you will use your own SQLite, which is incorporated in your own code.
Mm-hmm.
But you might say on old Android versions, I want to use the SQLite version of Android, which the new versions don't allow anymore. iOS still allows it. And so that switching is something that this PCL raw library will do for you. But since we want in every case to use our own instance of SQLite, um, it's all that switching is not so important.
Yeah. Yeah. That makes sense.
So I think I want to make it initially working with the SQLite raw layer in between. And then once I see that everything starts working, then we can put extra effort to do the translation ourselves and leave everything out.
Okay.
Um, but that last step is an optimization step. So um, as long as we see that all the tests pass, um, and if I really would run into problems with that raw library, okay, then we have to do it immediately. But I don't think in that raw library there are problems because it's used by
Mm-hmm.
uh, Microsoft library. It's used by PCL, no, SQLite-NET, and so I don't think there is really too much problems.
Yeah. Yeah. That makes sense. I think that is something we could rely on.
Mhm. And then for the connections, because now I'm back to using one connection per transaction. Um, if you read the SQLite documentation, it says it doesn't really matter whether you use one connection or individual connections. The only disadvantage in using individual connections is that you cannot prepare and reuse the statements. So actually,
Hmm.
a SQLite expression
Mm-hmm.
is under the hood compiled into kind of machine code for their virtual machine. And so if you use the same expression multiple times with different parameters, then you can reuse the compiled version, which is with
Right.
parameters
Yeah.
inside. But that's something, if you take another connection, you don't have that advantage anymore. Now, perhaps, but I didn't look into that, perhaps we can still use this compiled statements between connections. I found somewhere a library that seems to be doing exactly that. I
Huh.
didn't look into it. I didn't read further, but it might be a possibility.
Okay. Yeah. That. Yeah. That does seem like a an optimization to be looked at a bit later after we get something working. Um, and it might be, since what we're targeting is this is just a personal experience. It might be that the load on the database is not sufficient for that optimization to make any difference.
Mm. But it might be important on the server, for example.
True. True. Yeah.
Yeah. But even there, because there will be queues in front of it, so. But okay, there are things that's pure optimization that can be done later.
Yeah. Yeah.
The main thing is to have it working correctly. That's much more important.
Mm-hmm.
But so it has been proven reliable now.
Excellent.
That was quite interesting to dive a little bit into into C.
Yeah. Yeah.
Yeah, because
Yeah.
it's not a different from C sharp, but a completely different environment before you have it up and running and all these include files and why is it not working, and yeah, especially the pointer stuff that was a long time ago.
Yeah, I do remember actually writing business applications in C++, and and wow, I didn't realize at the time how slowly everything was moving, because we were thinking about memory management as we're trying to write a business
Hmm.
application. Um, yeah, and pointers to things, and then yeah, you get just you cast a number into a pointer, and then if you do that wrong, then program crashes. You get no information. Um, yeah, we're in a much better world these days.
Yeah, it's much easier. I don't say easier, but much more
Hmm.
comfortable.
Yeah,
Um,
yeah. Well, I think easier is objectively true. I think you can make that claim, because you don't have to think about so many different levels simultaneously. You
yeah, but
can um, trust the lower level, and and just express the behavior of your application using the upper levels.
yeah, but if something goes wrong, to find out what is wrong exactly.
Hmm.
Um, Luckily, the tools we have today and Visual Studio is enormous
Hmm.
for debugging. But still, if you can go back to basics and really start from zero, then you can. Uh,
Yeah. Yeah,
it's,
which is
it's
yeah, that's the interesting thing about what you've done here is somebody might look at this and say, well, why are you testing SQLite? We already know that it works. But what you're doing here is you're testing your knowledge of SQLite, um, so your understanding of the documentation and the way that you can put something together. So
because
yeah, going up from here now, it's testing your knowledge of PCL raw or BCL raw, and um, yeah, then building on top of that knowledge.
yeah, because it would have been surprised me that SQLite would not been working, but I might have misinterpreted the documentation.
Mm-hmm.
And in the end, you don't know anymore what it is doing. So in this way, I'm sure it works in that scenario. And now I can start looking. And on top of that, I will need that, for example, for that error logging. There are so many parameters, and with these
Mm.
pointers and relative addresses, and so it's nice if you can just try it out in a clean environment.
Mm-hmm.
Because
Yep.
calling
Nice.
calling calling DLLs from C# and from VB.NET, I've been doing that a lot of times, but most of the time it's a little bit copy paste and trial and error. And if it really doesn't work, then you go and look into it. But it's, if you can start it from basics.
Mm-hmm.
So okay, that
Okay.
problem is more or less solved.
All right, and I've made a bit of progress on the SQL generation for Jinaga.JS on the server side in Postgres. So I can do a share and show what I've been working on as well. All right. So, so the way that I started is I went back to this Postgres spec and verified that I could generate the correct SQL for a pipeline. So, so the way that this test works, we've got a start fact reference. So it just says, okay, here's a very simple little fact, a minimal fact. Let's dehydrate that. And actually, I'm not sure why I hard-coded the hash, but I think, yeah, that fact reference gives you the hash. Huh, I don't know. But at any rate, and then we've got this this SQL4 function that will take a descriptive string of a pipeline, and then it will turn that into an actual query. And then here what it's doing is it's building up the fact type map and the role map. So these are operations that would be performed inside of the SQL store, but for test, I'm just going to go ahead and assume that we've got a couple of tables that are storing our fact types and our roles, and we'll just generate some IDs and stick them into the map. And then we actually compute the SQL from those query steps, and then return that SQL and the parameters and the path length. We'll talk about that in a little bit, as well as the maps. And that allows me to do stuff like this. So generate the SQL for this pipeline. Just predecessor, parent. So along the parent role, find my predecessor, and then I can check the SQL. It should be equal to this query here. I can also check the parameters. So it should be the fact type ID of root and the role ID of root parent. So every role is declared by a fact, and then it's just the name of the field within that fact that points to the predecessor. So so it's always declared by the successor. So, so yeah, actually, if you think about it, this particular test doesn't really make too much sense because here's what root looks like. It doesn't have a predecessor. It's the root. But if it did, this is what the query would look like. So start at the F1 is the starting fact. So that's starting where the fact type ID and fact hash are the parameters. So that's why parameters 0 and 1 are the fact type ID and the hash. And then from there we join on the edge. So since we are doing a predecessor query here, so we know that this fact type ID or this fact ID here, F1, is the successor part of that edge. And this row is the parameter 3, and so that's the role ID of root.parent. So that's going to give me the predecessor fact ID once I follow that edge, and then I do that join to F2 because I've now gotten to the end of the pipeline, and select f2.hash. So don't need to select the fact type ID because that's that is known to the model. So I don't need to get that from the database. So then we we generate that that proper SQL. We've generated these parameters, and then here the path length is going to be equal to 1, and that's the number of facts that I actually end up selecting. And this comes back to the whole zigzag type of query. So if I join some successors and then turn around and start joining some predecessors, right there, that valley is that's a fact that I need to know about. So I consider that in this vernacular to be in the path to the result. So so the path length is always equal to the number of values plus the final fact if you do a predecessor join at the end. So in this case, we just select 1, and that's our path length.
So if you would go up first and then down, and then up again and down again, then you have a path length of 2, because you have one valley and your final fact.
Yep, exactly. Exactly. Yeah, turning the corner from up to down doesn't create a point in the path, and that's because you're going to end up doing a transitive closure, and you're going to get all of the predecessors, so you'll be able to see those intermediaries. So yeah, if you think about the transitive closure as this upward cone, then starting at each of the valleys and shining a cone up the graph, you're going to hit the entire graph that's participating in the query. All right, so so yeah, here we're able to, starting from some point, just get the parent, and here, starting from some point, we're able to get a successor. As long as we can tell you what the type of that successor is. So we have to have a fact type declaration at the end of every successor join. And so that gives us a very similar looking query, except that here predecessor and successor have swapped roles. So it used to be join based on the successor ID and then get me the predecessor ID because I was pointing up the edge. Here now join based on the predecessor ID and give me the successor because I'm looking down the edge. other than that, the query is exactly the same, and then the role ID that I use is the role defined in integration test.successor with the name predecessor. So it pulls those strings out and looks up with the role in the role map. So I think I've got a test in here. I thought I had a test in here that it should throw. Okay, yeah, right here. So if I just look for a successor, but I don't supply the type, then it throws an error saying that it's missing a type for that role. So it says, okay, you're looking for the role named predecessor, but I don't know which type declares that role. So I can't look it up in the map. So in Jinaga.net, the type system is such that you will always have that information. So the parser uses reflection in order to build the pipeline, and so when it's looking at field names, it knows what class you're in, and it knows that that class has a fact type attribute, and so it's always able to build a query that has the fact types at every point here. But in Jinaga.js, that is not actually the case. You could have a template function that says, okay, I need to match where your predecessor is equal to this parameter, but I don't declare a type within that specification template. So this is an exception that might actually bubble up to the developer sometimes. So hopefully there's enough information there.
Yeah, but so that's never going to bubble up in .NET.
Correct, yes. Okay, so in order to actually get this stuff working, had to do some pretty cool stuff.
Michael, but why did you put that error message in then? If we never see it in .NET.
So it so I had to put it in here because this is the Jinaga.js code, but even in the .NET code, I would have I would have an error message there that would, if it ends up never being hit because we know that code's encapsulated within this other thing, then that's fine. But if it does get hit, I want it to give us, you and me, information about what's going on, so we can fix the bug in Jinaga.net.
Oh, I forgot we were in TypeScript.
Yeah. Yeah. So this stuff right here, if we take a look at Postgres store, you can see that it is using, in addition to making all of its Postgres calls, it is using this SQL TS, and this is the code that's just generating all of that SQL. So we've got this SQL from steps. You saw the test was calling this function here. So from a particular starting point and a set of steps, using a couple of maps, get me a SQL query. And a SQL query is that SQL string, the set of parameters, and the path length. So the things that we saw in the test. So it's constructing this builder and then saying, all right, build me a query. So here is the query builder. So it's keeping track of a few a few things that it's basically the record keeping as it's doing the query building. So here's the next edge number and the next fact number. Because F1 is the starting point, the next fact is 2. So if it needs to allocate a new fact point within the query, which actually I should show you real quick. Let's jump all the way down to the zigzag pipeline. So here we are, starting from the root. Get me all of the successor assignments that point to this root as user. And then from those assignments, jump up to the predecessor project. So we've just assigned this user to this project. And so now we're at the type project. And then follow the successor project as defined by task. So the task is pointing up to its project. So we've just gone from this user down to the project down to the assignment, up to the project, and then back down to the task. And we're doing one more successor join for the task title. Excuse me, task reference. So along that path, we've got a valley at the assignment, and then we end up at the task title. So those are the 2 points along the path that we would expect. So we've got those 2 facts that we're selecting.
Was there not a third valley as well? At successor of project there.
Yeah, so that's followed by another successor. So
yeah.
So yeah, we're still on our way down to the valley.
Yeah.
Yep. And so so we start at F1. We do our edge join E1, pointing at the successor. And once we get there, it says, okay, I'm at a valley, so let me go ahead and put another fact join in there on that fact ID and call that F2. But then continue from there. So so we're still using E1 successor fact ID to continue down the joins. So now up. We've turned the corner, and so now we're going up to using E2's successor to find the E2 predecessor, and then we're turning a corner and using E4. Are we turning a corner here? Yeah. So E3 predecessor is looking at E2 predecessor. So now we're going down E3, so we find E3 successor. And then that's E4 goes down one more, and now we've got E4 successor, and that's where we find F3, the end. And so along the way, we've got the roles, the role IDs 3, 4, 5, and 6, and those end up being the roles user assignment, project task, and task title. And we end up with a path length of 2. So we know to expect 2 hashes on the result. So
why 2 in this case?
Yeah, so that is
we had assignment.
Yeah, that's the number of times that we have a fact joining here, which ends up as a hash in the select. So yeah, that first one is because it's a valley. So F2 is a valley, and F3 is the final fact.
Final, yeah. Okay.
Yeah. Yep. Yeah, I'm glad that it's a machine that's doing all of this stuff, because it's really hard to keep straight.
You you really make the drawing while you program it, or
Yeah, for this one, yeah, definitely drew it out. Um, and this is also reminiscent of a realistic pipeline. There would be some existential conditions in there, which the code also handles, but we'll talk about existentials later. Um, so uh, so yeah, that's why we are allocating fact numbers here, starting at 2, and allocating edge numbers starting at 1. And then it's collecting up a set of query parts. The joins are the part that we're looking at right now. Existentials will end up in there as well, but we'll talk about those later. And then these role IDs are the parameters. So when I'll skip down here to build SQL. Oh, okay. It is right here. So when I emit the parameters, it's always the start type ID and the start hash, followed by all the role IDs. So those are just the parameters that I give back to Postgres in order to execute that SQL. So in order to execute the SQL, it runs a state machine. So we start with this start state, and then we do a reduce over all of the steps, calling match step. So from each state, we match the step from that state, that step, and that returns a new state. And then we just keep on looping through that over all of the steps, and we'll end up at the final state. So start state is a query builder state. It happens to know this is query builder state predecessor type. And final state is a query builder state as well. And then at the end, we call end on that final state, let the state machine do one more tick, and then we have all the information that we need inside of these variables, in particular the query parts and the role IDs. So let's take a look at the state machine. We will start with this query builder state thing. Let me jump up to where that's declared. That is a union type, so it's a query builder state of predecessor type, predecessor join, or successor join. And those look like this. And of course I drew this graph. So we've got predecessor type, predecessor join, successor type, successor join. These are the 4 states that the machine goes through. And then when you end the machine from each of these 4 states, you'll end up here, either with a success or an error. So we begin in the predecessor type state. So this is, I know the type of the fact that I'm currently looking at, and I'm on my way up the graph. So we know the type of our starting state, and we know that by going up, we're not going to be creating a valley. So if from here I see another predecessor join, then I go to the predecessor join state. So I'm working my way up the graph, and along the way I emit an edge. So it's like, okay, I know I know the type that I'm starting at, and this predecessor step contains the name of a role. So let's go ahead and emit that edge. And now I'm at the predecessor's join state. And so if I'm there and I see type again, then now I'm back at predecessor type. So I'm back to a point where I'm walking my way up the graph and I know the current type. So keep on doing that, emitting edges. And then eventually you'll be here and you'll see now a successor join. Okay, so now we are in the successor join state. Here we don't have enough information to emit an edge yet, because we need to know the type of that successor, because it's the successor that declares the role. So we know the role, we captured that from the step, but now we have to wait for the type declaration before we can emit the edge. So once we see that type declaration, then we can emit the edge, and now we're at the successor type state. And so we keep on following those successors, emitting the edges upon the type declaration as opposed to on the step declaration. Then finally, we're at successor type, and we see, okay, now we're joining back to a predecessor. So this is where we know that we are in a valley. So we can emit the fact, because we need the fact for that valley. And we also emit the edge because now we're about to jump up to the predecessor, and we know the type that we're starting at, and we know the role for that predecessor. So we have everything we need in order to emit that edge. And that takes us to predecessor join, where we can start going back up the graph as well. So yeah, you'll see a bunch of loops here, jump over here, loop here a little bit, jump back, and it detects the valleys.
Code behind is going to be complicated.
Yeah. So with this this union, that's basically creating a type for each one of those different states, and these are the different types. So in TypeScript, you can declare a discriminated union by creating different types for each of your different states, and then have the discriminator be a constant. So so here, this constant string predecessor dash type is a type itself. So it's not just generic string, it's a specific string. So so if the state is equal to that string, then we know that it's a type of this particular interface, and we know that it has a type ID field, and we can grab that number. So the predecessor type and the successor type states both have captured a type ID. So if we look at this again, we can see predecessor type and successor type. In both cases, we just received a type, so we can look that up, and we store that inside of the state. So we're just kind of holding on to that until we need to use it. And then if you're in the predecessor join state, you don't have any extra information that you're holding on to. So predecessor join, we've already used up the information. So we've emitted the fact, we've emitted the edge, or coming from here, we've emitted the edge. There's no information that we need to hold on to that we haven't already used. So then here, the successor join, we're holding on to the role. So successor join, we've followed a successor edge, but we don't yet know the type, so we have to hold on to the role, waiting for the type before we can emit the edge. So we're basically keeping track of the current state of the machine inside of these states, whereas we're keeping track of the data that we've generated for the query inside of the query builder class itself. And so then this gets into the the really fun part. So now we're going to match a step. So we're at a particular state, and we see a step. What do we do? So first of all, break it down by the state, well, the state field of the state, and so it's got to be one of those 4 constants. So the type is the union of those 4 constants. And then if it's a predecessor type, then we know that state at this point is a state predecessor type. So the conditional keeps track of the states, the actual types. So break that down into these 4. And then once we're inside, we can do all of our checking for the step. So these steps are excuse me, actual JavaScript instances of classes. So so here I'm using the actual class type rather than discriminated unions, but it's a very similar idea. So if the step is a property condition and its name is type, then that's f.type equals, and so I've got the value, that's what it's equal to. So this particular pipeline syntax allows for just any old property condition, but since then I've constrained that and say, well, all property conditions are type. So eventually this will get simplified and you won't be able to specify the name. You'll know this is a type condition. So you've just matched the type. You're in the predecessor type. So you're here. You just saw type. There's no arrow leading out from this, but it's still something that we can do something sensible with. It's just not progressing the machine any. So really all it's doing is checking to see, is this equal to the same type that got me here in the first place? So do I have 2 type declarations in a row? If so, if they're the same type, no harm. If they're different types, then that's an impossible pipeline, and I'll just throw the exception. So a little bit of error checking in there. The useful part of this code right here is if it's an instance of a join, then when I join in the predecessor direction, then I'm going to go to the predecessor join state. So I'm here, I see a join in the predecessor direction, I go to the predecessor join state, and along the way I emit an edge. So I call emit edge, it's a predecessor edge, and here's the role ID. And then I end up in the predecessor join state. But if it's a step in the successor direction, then I'm following this line, and I end up in the successor join state. Don't do any emits. And then continue from there. So while I'm going through the machine, I'm calling emit edge and I'm calling emit fact at the appropriate transitions. And so that's allocating an edge ID and then adding an edge join to the query parts. Or if I'm emitting a fact, then I allocate a fact ID and I push a fact join into the query parts.
Yeah.
So I'll make it through the whole thing, and then I can assemble those query parts into SQL.
I think I'm gonna step through it with the debugger.
Yeah. Which fortunately works now.
Yeah. So that's for things like that I need it.
Mm-hmm.
Uh, yeah. It's
Yep.
complicated code.
Yes, it is. It is. But yeah, that's getting us to a level of abstraction that now you can just declare the behavior of the application, and then the complicated code.
Mhm.
There's a machine working on that.
The SQL comes out of it, and we send it to the database, and it's okay.
Yep.
Mm.
Yep. And because of all of the optimization that we just did at the database level, by using just integer IDs for foreign keys and that kind of thing, then we know that the generated SQL is going to execute quickly, even if it is kind of a large chunk of SQL. As long as we can stay under the 64 join limit.
Yeah.
So yeah, it'll be
It was 64 joins for SQLite.
yeah, it'll be interesting to see how complicated your data model has to be in order to exceed that. So yeah, I think that is something that that I'll want to be able to tell a really good story around. It's like okay, here's the most complicated useful thing that you could do for a screen, and then it can handle up to this, and then once you get there, what do you do? Well, you're gonna have to break your user interface apart into different screens, because you're putting entirely too much depth into one query.
Because you had with the old system, you had performance problems with the core system for improve.
Yes.
If I understood well.
Yes.
That one is dependent on the Jinaga server, the JS server.
Yes. Yeah, that uses Jinaga.JS.
Yeah.
And it uses the version of the database that joins on strings. So all of the edge joins are on the on the fact hash, which is the base 64 encoded hash of the fact, and then all of the roles are just the role names.
But that means you need this first to test out what the improvement will be with the indexes.
Yes, that is true.
And then you will have to translate all the facts, or how will you do the the migration?
Yeah, that is that's actually a pretty exciting opportunity here. So if you do Jinaga server and you do Jinaga server config, there is a is that it? I believe that's it. This HTTP endpoint, let me see where that's used. Yeah, that's used right here when we're creating a fork. So if you provide an HTTP endpoint when you're setting up your Jinaga server, this will create a connection to another Jinaga server. And so any facts that you emit, that you save in this one, will go to the other one as well, and any queries will pass through. So the query will be executed locally, and then it will do the query remotely, merge the two results, and give you back the results. And so the migration strategy is have a version 1 server and a version 2 server. Reconfigure version 1 to let's see, actually, the other way around. So configure version 2 to point to version 1, and then as you're running the application, you're running the queries. The version 2 server will execute those queries on version 1, bring those facts in, merge them, give them back to you, but also store them itself. So you don't have any database to database migration that's happening. It's just this new instance is going to populate its own database from the data that it receives from version 1.
Okay. That's something that was already in the server?
Yes, indeed. Yes, and I have tested that out a couple of times. One was when I was updating the excuse me, updating the schema in a more simple way. It's like I could do a database migration, but yeah, this should work. And I tried it, and yeah, it worked. Mm-hmm. And the other time was when I was trying to grab a subset of the data locally in order to work on. So I said, okay, let me create a local server, pointed at my remote server, run the query. Now it's got all of that data cached, and it's serving up all of these queries quickly.
Mm. Okay,
yep.
That might be another migration strategy.
Yeah. Yeah. And that's also a good one for doing any kind of archiving. Excuse me. So you've got your periodically you'll say, okay, I'm going to take my my old I'm going to take my application. I'm going to make that the source. Put a new empty database in between.
Yeah, you roll over in the new database, but only the facts that you really use.
Yep.
And the ones that you don't use stay in the old one.
Yep, exactly. Yep, and then eventually you can move that to cold storage, do that swap again. So yeah, there will be I kind of foresee some DevOps tools to make that easier. So you can just kind of say, all right, I'm going to set up a schedule. So every quarter, I'll just move that chain along. So so that one goes into cold storage. This one goes into warm backup. Yeah, that one becomes your new server.
Okay. But that's for later. Good. I know what to work on.
Excellent.
Yeah. Get the database working first, and then catch up with all the things you are doing.
Yeah, hopefully it'll be a pretty simple translation with the ability to step through, and then also to kind of think about how would this TypeScript code look in .NET, but then also the .NET pipeline has gone beyond the JavaScript pipeline, so so it can record more. It can fork within the query. So what does that look like? How does that change things?
It's going to be a challenge.
Yep, but you're not doing it alone. So once you get us to the point that we can make those SQLite queries, we can share that burden.
Luckily, I'm not doing it alone. I would not get there. But no, it's interesting to have a sample in one language and to have to think about it in another platform, because that forces me to really understand it.
Yeah.
There are so many. The principle is easy, but if you go to the implementation, try to follow everything. It's not. It's good that it's a computer who's gonna do all the fact processing.
Yes. Yes, indeed. Yeah, and then eventually we'll turn on GitHub Copilot, and it'll be smart enough to write all of that code. So then we'll just speak our requirements to it, and it'll just tick.
I was saying to Copilot, I want to program something. Go and look to the GitHub of Michael,
Uh-huh.
and I don't have to do anything. It will bring out the code for me automatically.
Yeah.
I haven't been using Copilot for the moment. Do you use it for
Yeah.
everyday programming?
Yes. Yeah. I was a bit cautious for a little while, and then got pretty comfortable with with how it works and the security model that it's using in order to make sure that that the code that I'm writing with it doesn't leak out, doesn't end up in somebody else's library. So yeah, if I commit code to a public repository, yeah, absolutely, that GitHub Copilot is trained off of that. But yeah, the code that's in my project, I'm confident that that's not being used elsewhere. But I do see that it is being used within my project. So I'm going to write something else very similar to something I wrote in a different file or in the same file, and and it's like, oh, I see that pattern. Yeah, here it is. It's perfect. That's exactly what I'm trying to do.
Yeah, but does it do that automatically? If it sees that it's a private repository on GitHub, it will not utilize that code for somebody else, or
Right.
do you have to set it up differently?
No, no, that is the way that it is set up by default.
Yeah.
So yeah, it will suggest code that's similar to what you see in public repos, and it will suggest code that's similar to things you see elsewhere in this same project.
Okay.
And that's the magic of these of deep learning. Having multiple layers. You can train a model on one set, and then you can have something else that's kind of derived from that model, and say, okay, these are some of the other layers, but let me mix in some local domain knowledge, and just do that training really quickly right here within a constrained scope, and then throw that away.
Okay, because in the beginning you were very enthusiastic about it, but so you still are.
Yeah. Excuse me. Goodness. Yeah, I am. I'm pretty happy about it. And maybe it will work with the in that Star Trek future that I keep talking about. Who knows?
If I have some time, I will install it also to try it out.
Yeah.
Good. Okay.
All right.
Yeah, we are getting overtime.
Yes, indeed.
You have to go and work.
Yeah.
Next,
still have the job.
Next week, available, Michael?
Yes, indeed.
Okay. Good. Don't get a cold in meanwhile.
No, these are allergies. I've already tested negative. I know that it's not COVID. It's just allergies.
Keep away from COVID because it's an endless story.
Yeah, it is. All right.
By the time we finish this project, there will be no COVID anymore. Okay.
Yeah.
Michael, see you next week then.
All right. See you, Jan. Thanks.
Bye-bye.
Bye.